Let us find cosine of negative 7 pi over 6. You can convert this angle to degrees if it is more convenient for you, but I prefer to find this angle on the unit circle in radians. So 7 pi over 6. Pi is the half of the circle, or the straight angle. Our angle is negative, so we will move in the negative direction or in clockwise direction from positive x-axis. Each quadrant contains 3 increments, pi over 6 each. So the half of a circle consists of 6 such parts, 6 pi over 6. We need 7, so it is the next pi over 6 in this direction from pi. This angle is the same as pi or negative pi over 6. From this angle will be negative pi 7 pi over 6. So this is our angle. The reference angle is pi over 6 or 30 degrees. The cosine of this angle will be the same as cosine of pi over 6, but it will have a negative sign. It will be negative cosine of pi over 6, or negative cosine of 30 degrees. Recall our reference 30-60 triangle. 30, 60, the hypotenuse is 2, shorter leg is 1, longer leg is square root of 3. Cosine is adjacent over hypotenuse, so cosine of 30 degrees is square root of 3 over 2, and the cosine of negative 7 pi over 6 will be equal to negative square root of 3 over 2. Let us find sine of 2 pi over 3. Two pi over 3, let us use the same circle. This time we move in a positive direction. The straight angle of pi is equal to 3 pi over 3. So 3 pi over 3 plus 3 pi over 3 plus 3 pi over 3. So 2 pi over 3 are here. 2 pi over 3. And it is the same as 120 degrees. Sine of, you can replace pi with 180. 2 times 180 degrees over 3. 180 over 3 is 60. 60 times 2, 180. Sine of 120 degrees. So, whichever method you prefer, doesn't matter, important that you locate this angle correctly. Then we want to find sine of this angle. The reference angle is 60 degrees. So this is the reference angle, theta prime. Theta prime is 60 degrees in this case. We consider the same reference triangle. Sine of 60 is opposite over hypotenuse. Sine of 60 is opposite square root of 3, opposite of 60 over 2. Now the sine of 120 will be equal to sine of 60, the sine of reference angle, with maybe a difference in the sign. So the sign is y component, y over r. y in the upper half of the unit circle is positive, so sine of 2 pi over 3 must be positive. Will be equal to square root of 3 over 2, positive. Let us find all values of circular function s, sine of s, if sine of s equals to square root of 3 over 2. So let us consider s on the interval from 0 to 2 pi, one rotation. Positive sign can be by the angle in the first and in the second quadrant. Both angles have the same reference angle. So, and we can find one of them will be just equal to reference angle, and the second angle will be 180 or pi minus reference angle. If we need to find the values on the interval from 0 to pi, then we use radians for all measures. We must find the angle that have sine function values equal to square root of 3 over 2. You remember already it is one of these special angles 30 or 60. Sine is the opposite of a hypotenuse. So if you look on this triangle, 30-60 triangle, you will see that opposite of a hypotenuse equals square root of 3 over 2 for 60 degrees angle. So S must be equal to 6. So if it were an angle, it was 60 degrees. Since it is a circular function, we take the same in radians. It is pi over 3 radians. So and so I've written here theta prime, but you can understand it as s prime. So we have two values of s, pi minus pi over 3 and pi over 3. So pi minus pi over 3. So let us represent pi as 3 over 3 times pi. 3 over 3 is 1. We can multiply by this number. So we have two numbers with the same denominator, 3. 3 minus 1 is 2. 2 pi over 3. So the solution set is pi over 3 and 2 pi over 3. So don't forget that we always have same as two angles with the same trigonometric function value. Let us find s if cosine s equals negative square root of 2 over 2 on the same interval from 0 to 2 pi. Let us sketch two possible angles. As usual, there are two. Cosine is x over r, so we look at the x component. X is negative, the two angles, so we'll have two different angles in the second and in the third quadrant. Reference angle, if we talk in terms of angles, reference angle, the prime is 45 degrees or pi over 4, or you can, if you have a unit circle chart, you can just look on this chart which points have the cosine, the x component equal to negative square root of 2 over 2. Or you should actually remember this already, that the angle of 45 degrees, so pi over 4 has sine and cosine values equal square root of 2 over 2 or 1 over square root of 2. So we have two values of circular function or two angles. Maybe it's more convenient to talk in terms of angles. So the straight angle is pi. One angle will be pi minus pi over 4 and another is pi plus pi over 4. So actually you don't see any difference between making a solution for circular function or making a solution for an angle in radians. So there's no difference at all. Circular function just explain us why we use it in pure mathematics, but from the point of view in our problems, it's completely the same. So the first angle or the first circular function value is pi minus pi over 4. The second is pi plus pi over 4. So we want to add these two fractions. To add fractions, we need the same denominator. So we multiply pi by 4 over 4. Now we have the same denominator, 4. 4 minus 1 pi or 3 4 pi or 3 pi over 4. And the second one, also we multiply pi by 4 over 4. 4 over 4 is 1, that's why we don't change anything. So we have the same denominator, 4. In the numerator, we can write 4 pi plus pi will be 5 pi over 4. Here I factor out for pi, here I have not. It's actually up to you how to solve this fraction.